Hello everyone and welcome back. I am Mr. Cobalt and today we are going to use our balanced equation to do a mole to mole conversion. So we're going to be using stoichiometry and we're going to be using the mole ratios in our balanced equation, the coefficients as mole ratios in our balanced equation to convert from moles of one substance to moles of another substance. So here's the first problem. So first I want to remind ourselves of this roadmap that we have. And this is a very useful roadmap when we're doing stoichiometry problems and chemistry problems in general. So the roadmap, and this is what I've called in other videos the chemistry conversion superhighway, is if we have mass of substance A, then we can convert substance A to moles of A from grams to moles using the molar mass of A, MMA, molar mass of A. Once we have moles of A, we can convert from moles of A to moles of a different substance using the mole ratio. And this mole ratio could be a ratio that we get from the formula, right? So the formula can give us a mole ratio of the whole formula to part of the formula. But we can also get that mole ratio from our balanced equation. So if this is our A and this is our B, then we can use the coefficients as the mole ratio. So we can convert between moles of A to moles of B. And then if we need to get to grams of B, then we can use the molar mass of B to convert from moles to grams. So wherever we get onto this highway, the highway will tell us where to go and how to get there. Okay, so in this particular problem, we're focusing on going from moles to moles. So we don't really need the gram part because we're not gonna start here. We're actually gonna start here. So in this problem, it is asking how many moles of water are produced from the combustion of 22.0 moles of octane. And octane is our C8H18. So we want to go from moles of octane, so they gave us moles of octane, and they want us to find moles of water. So in order to go from moles of octane to moles of water, you need to use the mole ratio in the balanced equation. So you need the balanced equation to help you answer this question. So they give that to us here. So we have 22 moles of octane, so this substance here. And they want to know how much water is produced in moles. So this substance here, so water and octane. So we're going to be using the coefficients 2 and 18 as our mole ratio. So the way we want to set up the problem is start with what they give you, 22.0 moles. So we have 22.0 moles of our octane, so C8H18. You don't need an I. So over 1. And we need a conversion factor. And so that's where the mole ratio comes in. We're going to use the mole ratio as a conversion factor so we can convert between moles of one thing and moles of the other. So given our equation, we know the ratio is 2 moles of octane is to 18 moles of water. So if we burn 2 moles of octane, we get 18 moles of water. That's the ratio. But we have 22 moles of water, or of octane. So what we're going to do is we're going to put 22.0 moles. Well, we have moles of octane here, so we need moles of octane on the bottom. So we're going to take 2 moles. So 2 moles of octane goes on the bottom. We're using the mole ratio. 2 moles of octane, C8H18. And then the 18 moles of water goes on top. So 18 moles of water. And so moles of octane cancel out. And now I have moles of water on top. So now all I need to do is multiply and divide, and I'll get my answer. So you can use the mole ratio between any two substances. Here we're using 2 to 18. So 2 moles of octane to 18 moles as a conversion factor. And so we can do that with any problem. So here we can figure out the moles of water. So now we have moles of water. So all we need to do is just multiply and divide. So here we take 22.0 times 18 divided by 2 equals, and we get 198. So we get 198 moles of water. Okay, so that's a lot of water. All right, so now at this point, we have to go back to our sig figs. So we're not done with the answer yet. So this is what our calculator gave us, and so we need to figure out if we're allowed to keep all those digits. So we need to eliminate anything that's exact is eliminated, and then we look at whatever the measures are, and the answer should be in the same number of sig figs as the least number of sig figs. So looking at here, we have the 2 to 18 ratio. That came from our coefficients. These are not measures, these are exact numbers. So 2 is exact, 25 is exact, 16 and 18, they're all exact. So we are going to ignore those for our sig figs. So the only one that's left is this one here, and that's 3 sig figs. This 0 is significant because we have the decimal point. So 3 sig figs is the least number, so we should have 3 sig figs. So we have 3 sig figs already, so 198 is the correct answer. I hope this was helpful. This is how you can use the balanced equation to do a mole to mole conversion, and the way you do that is whatever two substances you are converting between, you use the coefficients as a ratio. So 2 to 25 or 25 to 16, whatever the case may be, depending on where you're converting from and where you're converting to. Again, I hope that's helpful, and if you like this video, like the video, share the video with your friends, subscribe to the channel, and make a comment in the comment section. Let me know how what you think and what you would like me to go over. And also make sure you hit the notification bell. And thank you for joining me, and I'll see you next time.